Hello, I'm Shyam Haridas.
And I'm Atharva Pandare. We're interns here at 3S Analytical Technologies. First, I would like to take this opportunity to thank the founder, director, and CEO of the company, Mr. Sarang Saranko, for giving us the opportunity to intern here at a place where they have state-of-the-art machinery such as HPLC, LCMS, and FTIR.
There are other tests as well. So students out there, researchers or analysts. So if you have some samples that you want to get analyzed, contact 3SAT because we have reliable research with speed and accuracy. So again, thanking Sir because he has given us the opportunity and he has allowed us to share this video with the with you guys. So today, let's get back to the video now. So what we're going to do is building a model. So why did I take this? This is because these are the samples, these are the standards. Sugar solutions of varying concentrations will be read by the FTIR here, hello there, and we will make a model out of that, and the model will have a calibration curve. So the calibration curve will have a specific equation based on the peak heights and the peak area, and hopefully the R square comes, it should come from 0.95 to 1. And if the R square is like that, it is very good, and your equation is good, and your model is good. So we'll get back to the screen recording to show you how it works, how to make the model. So I want to show you one sample, which is the unknown sample. So I know, and he knows that it is 300 mg per ml, but the FTIR doesn't know. So we will try to see if the 360 mg ml. Yeah, it's 360. In the video, I'll show you what it is, and we will see whether this FTIR can actually find it out or not. So let's get to the video. Right, welcome to the video. So the screen recording is here right now. MicroLab PC has been switched on, FTIR is switched on, and now we will select the method, the glucose quantification test. I'll show you, we're doing data collect only method type, and we are also doing absorbance. The spectral range is from full range, from 4000 to 650, since it's zinc selening. Now we save it and click on activate. You should see, click on this, okay, click on this and then click on activate, and then this should be written here as the same thing that you saved there. Click on start, clean the crystal and reload the sample. So we have cleaned the crystal, and now we are placing our sample. This is blank, just water, and we'll click on next, give the name as water blank 10 July, and save it. Water blank, a typo there, water blank 10 July. Click on next, it will sample, and let's see at this spectra how it looks. So this is how it looks. So this whole part is the water part. Okay, you double click here to go full scale. Yes, that's how water looks. Now we'll add the sugar test. Now we click on home, again click on start, clean the crystal, put some IPA onto the crystal and clean it so that there's no previous sample there, and put in our sample. Click on next. It's checking the crystal now, and it's collecting background information, and now we are set to go to put our sample. There we go, we have placed our sample onto the crystal, and we click on next, and we will name it as 20 mgs. We'll name it as 20 mg sugar, glucose, 20 mg glucose, 10 July. Next, let's see if there's any changes in the spectra. So you should see here there is a little bit peak. It's very less, it looks like noise, but there is actually a gradation here, there's a change. So let's go full scale. Now let's try the next one. Cleaning the sample again, click on start. The status is not ready. I will show you one more sample, and then I will show you I'll take you to the video where we go to the X sample. The IP has been poured, and now we are checking the background. First we have cleaned it, now checking the crystal if it is clean, and now it will collect the background info. Yes, now we will put our 40 mgs. Hopefully with this we'll be able to see some peaks, fingerprints for glucose. Alright, click on next. Yes, and this is our 40 mg 40 mg glucose. Let's take the next. It's sampling, and the peak is actually increasing here also. Again, save this. Now let's put 60 mg. We're cleaning the sample. It's done. Click on next. The crystal is clean. Click on next. The crystal is clean. Now we can close this and we can open MicroLab Quant. Key in the password ASAP. Enter and click on start new model. Get all the results, that is the standards that we had inputted into the FTIR. So let's look for it. So first we'll put the highest one. So we have 500 mg gluc 10 July, and we have 400 mg gluc. 400 mg gluc. This was actually a standard, like we had recorded more standards so as to get more accuracy. So we have 400, then we have 200 mg gluc, then we have 100 mg gluc, then we have 80, 60, and we can also put 50 mg gluc. We can put 40 mg gluc, 20 mg gluc, and then we can also put the blank, water blank, which is this. So then click on next, and we can key in everything now. First 500, this is 400, 200, 100, 80, 60, sorry, 60 mg per ml, this is 20 mg per ml, and 20, I think there's 2 actually, by mistake, we can remove one, remove this, yes, and this is 20, this is 40, and this is blank, see, yes, and they can click on next. So now I want to show you that this part, let me show you this way, this part is actually water, till here is water, this whole part is actually water, fingerprint of water. That's why we record the blank to distinguish between what is the blank and what is actually our component. So, and this part, let me remove this part is actually our water, sugar ka fingerprint. So let me go full scale and let me zoom in here, and so this part is actually water. This whole thing is the fingerprint of sugar. And let me remove the model and let me show you. This is water blank 10 July, then we have 20, let's zoom in a bit more, 20, then we have 40, then we have 60 higher, then we have 80 higher, 100, 200, 400, and last but not the least 500. And this is how you saw the concentrations kept increasing of the standard. And now we need to use this to get the peak area. Let's get the peak area, and we can set it from here to here. Alright, from here to here, and store the value. Alright, and there we go, 99664 is the R square value, which means all the points are actually going into the linear fit. So one thing I want to let you guys know is, now any sample that we have and we want to know its concentration, we have to make sure it is from concentration 0 to 500 mg, like we should know. But if you don't know the concentration, we can put in more standards, let's say till 2000 mg per ml, and we can input more standards and make the model more accurate. And then we click on finalize model, save the ML Quant project as sham glucose ML Quant sham glucose test, ML Quant sham glucose test. Let's keep it as ML Quant, let's give it ML Quant sham glucose test. Alright, and click on save. Then we can click save ML project. Yes, this has been saved. Basic, save, and create new MicroLab method as ML Quant sham glucose test. Okay, click on save. Then we can close this and open MicroLab PC for the software to open. Okay, now we've cleaned the password again. Enter. Now click on methods and search for ML Quant sham glucose test. So we have this one, which is, yeah, this is the most recent one. Click on activate. Alright, it has been activated. Now we click on start, clean the crystal, which has been done. We'll check the crystal. Background is being collected. And now we will put in our sample in a moment. Let's call it Sam. Alright, the unknown is, let's call it Sam, because my name is Sam. Let's call it Sam, and the unknown is actually around 360. Okay, it's 360 mg per ml, and the FTIR doesn't know this, but hopefully with the model, not hopefully, actually we should get it, since our R square is very nice. It's 0.99. So let's try it out. Now click on next. yeah, and there we go. We have our component 356, which was, we had put 360, it has come 356. So yeah, it's pretty accurate. So thanks for watching.